The best technical standard ever created came from one of the worst code bases in Unix history. I'm talking about Syslog, which has been the backbone of logging for 45 years, and we have SendMail to thank for it. If you've ever been exposed to SendMail CF and M4 configuration systems, that should strike fear deep into the bottom of your heart. But Eric Altman got one thing absolutely right. When he wrote Syslog in the early 1980s, he made it simple. So simple that it became the de facto standard across Unix-like platforms and even network equipment. It took almost 30 years before there was even an official standard with RFC 3164, and later RFC 5524 wasn't ratified until 2009. The power that made Syslog the de facto network standard? Its simplicity. Hi, I'm Jack Neely, and I'm an independent observability architect and owner of Cardinality Cloud, LLC, where observability is leverage, not tax. I have 25 years of experience doing SRE and DevOps work, more than a decade of that as an observability subject matter expert. I'm writing the book on being on call. If you've ever experienced the on-call pager rotation from hell, I bet you're looking for the solution. And I've got it. Look for the preview link in the description below. I'd love to get your feedback on the project. Today, let's dig into what logs really are. What's your biggest log challenge right now? Drop a comment below. I read every one, and they help shape future videos. If you're using a modern Mac, you still have Syslog compatibility APIs on your system. Linux or BSD user, you're still actively using a modern Syslog right now. So let's take a closer look at how Syslog messages are formatted. What's made this format last 45 years? And more importantly, what can we steal from it for our modern logging techniques? There are three primary parts of a Syslog message. The first is the priority. On the network, this is a 3-digit decimal number inside angular brackets. This encodes the facility, what part of the system generated the message, and the severity, what we know today as log levels. The upper 5 bits are the facility, and the lower 3 bits are the severity. To me, the severity is most interesting. We still use these log levels in many places today. Likely in the code you're actively writing right now. Look familiar? If you're using Log4j, Python's logging module, or basically any modern logging library, you're using a derivative of this 45-year-old standard. The second part is the header. Following the priority is the timestamp and host name, or the host ID. A very simple format. But no year and no time zone? WTF? Finally, the message. This was normally, but not always, formatted as a tag followed by square brackets containing the process ID. The tag was usually the process name. Following this was an arbitrary string message. The full message would look something like this example. Simple, right? Maybe too simple. Let's see what happened when they tried to fix it. RFC 5424 fixed the obvious timestamp issues, while also adding support for the structured key-valued pairs. But this included a namespace standard as well, kind of like LDAP, and it was never widely adopted. Folks were more likely to put JSON in the message field instead. This was 2009 after all. In hindsight, using the advanced features of RFC 5424 made using Syslog much less simple and much more enterprisey. Still with me? Let's get practical. I bring in the history of logging because it is the oldest observability signal. There is quite a bit of well thought out practice for dealing with pipelining and analyzing logs. Our goal is to always have better logging practices than Syslog. We stand on the shoulders of giants, and those are large shoulders indeed. As with metrics, logs are also a specific data type in the observability space. They are definitely the most flexible observability signal too. If you haven't seen my What Are Metrics video, I'll put a link in the card above and in the description, but more on that in later videos. Think of a log as a row in a database table. Actually, a wide database table with many columns that we'll call fields. Each log can have a large number of possible fields, but use the same field names consistently to make your database queries simple and efficient. If an IP address is a common field used in your applications, make sure it's logged with the same field name everywhere. As an observability engineer, when I pipeline logs to a centralized platform, I will also make sure to annotate the logs with the pod, the service, the namespace, Kubernetes cluster in a similar and standardized way. The best thing about logs is that there is no limit in the value assigned to a specific field. This is different from metrics in that it does not cause a cardinality explosion. So use unique identifiers, transaction IDs, usernames, etc. to make them fully descriptive of the event they describe. So how do we create effective logs in our applications? I've developed a framework called the search method that I cover in detail in another video. Again, link in the description. But let me give you the quick summary here, because these are the fundamentals you need to know. Logs should be structured JSON with a flexible schema. Log errors, including stack traces and error IDs. Always audit the action, read, write, get, post, etc. What resources and users were affected. Log status codes and use log levels. Always include a human readable message field. Let's dig deeper into log levels and what each level should be used for. I'm going to use the common log levels from Log4j. Trace. When you need to trace logic through each function, method, database call, IO operation, etc. Most likely you want to use the observability tracing or profiling signals here instead, but this exists and works well for deep problem solving. Debug. Diagnostics helpful to more than just developers. Think about on-call. However, expect that this level and higher may be filtered in production. Info. A wide event for every API call or transaction. Warn. Any condition which might represent a future issue or that the application has self-recovered from without being visible to the user. Error. Any condition in stack trace that caused a user visible failure. Now, here's where most teams get it right in theory, but wrong in practice. Use the info level for canonical or those wide events. Ideally, every API call or transaction should emit one log that is this canonical log event. I always think about Apache or Nginx logs as a great example of what canonical logs are. While they're not JSON, they are well structured and contain every single detail about the HTTP request. However, you should use JSON. The log data type does have downsides. The most obvious is that it can be incredibly voluminous. I've dealt with logging platforms handling hundreds of terabytes of log data per day. This can make them very expensive to store and slow to analyze. Usually, I do not use logs for real-time analysis or alerting, although with modern stacks, this is easily possible today. Unstructured logs are fragile to parse, as subtle changes can break the complex regular expression matching patterns. They also require more advanced tools, also known as more expensive, to parse and analyze. Not following best practices on the application end causes exponentially more expense on the platform end. Cardinality-wise, while a field name in a log message can have any value, the number of fields or columns that can be realistically supported is limited. You can only have so many columns in the database table before things become inefficient. In OpenSearch and Elasticsearch, I think the default limit is 1,000. I remember configuring this to 3,000 index fields. So please use a field mapping. Finally, watch out for SDKs that encode logs directly in the application and stream or batch them in a binary format directly to a collector. I'm looking at you, OpenTelemetry. If the observability pipeline goes down and you can't debug the money-making part of your business or recover from it, that's a bad situation to be in. Be careful of the blast radius that can exist here. All right, we've covered a lot. Let's bring it home. So what are logs? Logs are data. Logs are rows in a database of transactions. Logs are canonical events. Logs are structured JSON. Logs are schematized. Logs are the next generation of Syslog. Logs are human readable. So what's next for Cardinality Cloud LLC? I'm working on a new book. I've worked with countless teams to pull them out of unsustainable on-call rotations. Over the years, I've built a specific practice around how to dig out from hundreds of pages per day. Is this you? Are you interested? Check out the preview available on the Cardinality Cloud website. Links are in the description below. I'd love to hear what you think, but better, I'd love to include what's worked for you for a happy and healthy on-call rotation. If this helped clarify what logs really are, share it with your team. And I'll see you in the next video.